Hello and welcome to Maths Athlete. Today we'll be discussing polynomials and factorizing polynomials. So let's begin. So reminding ourselves from GCSE, we can remember that how to factorize a simple quadratic. So like say we're given, uh, x squared plus 4x minus 5, equals 0, and we're asked to factorize it. We know that from inspection, we know that we need two numbers that multiply to make minus 5 and two numbers that add to make 4. And so we know that we can use 5 and minus 1. So we can write it as x plus 5 and x minus 1, because x times x is x squared, and then x times 5 is 5x, and then minus 1 times x is minus x. So okay, let's multiply this out. So it'll be, let's use more than one color. So this will make x squared. This is, by the way, a revision, so hoping you already know this. Let's write the x properly, and then we have this into there. That's minus x, or minus 1x, and then you have finally 5 times minus 1, which is minus 5, and this all simplifies to make x squared. 5x minus x is 4x minus 5 equals 0. So these are the two factors. Anyway, that's a little revision, to get your brains pumped and everything. And these are two forms of linear factors. A linear factor is, let me draw a graph like that, and like that. So linear factor is always straight, basically. Linear means, line, comes from the word line, and pardon my Latin, so this would probably be, let's make that, so it intercepts at 5, so this will be x plus 5. Doesn't really matter about the brackets, you can forget the brackets. This is y equals, or yeah, exactly, y equals, where did I get 0 from? Y equals, yeah. So that's basically what a linear factor is. I'm just showing this because this will soon come up. Okay, so let's get rid of this. So hopefully that little revision should have got our blood pumping, basically. Okay, so say now we're asked to give the polynomial px. Px is just like a function, basically. Yeah, so like y is a function, and so on. So we're given the polynomial, or the cubic, x to the 3 plus x squared minus 8x minus 12, in the form of 3 linear factors. So we passed the previous slide, we had 2 linear factors from the quadratic, but now we're asked for 3 linear factors. Let me actually write that for emphasis. 3 linear factors. So we're asked, and there are many ways. We're asked to put them into 3 linear factors. There are 3 ways in which you can do it. There's probably like millions of ways, but these are 3 famous ways. The first way, let's use it in red. The first way, so number 1. First way is trial and error. It's something we've done in, again, GCSE. I'm always referring to GCSE, so we always know where we are. Okay, the trial and error. So basically we'll just keep on plugging in numbers, basically substituting numbers in for x until this equals 0, which therefore means no remainder, right? If we've learned the remainder theorem, or if you haven't, I'll explain right now. If you plug in a number into this function and it equals 0, therefore no remainder, therefore it's a factor. So let's plug in 3. So let's do P3. So x is now 3. So we have 3 cubed plus 3 squared minus 8 times 3 minus 12. And if we simplify this, this is 27, this is 9, this is 24, and this is minus 12. And simplifying even more, 36, add these together, minus 24 minus 12 is minus 36, which equals 0. And if I draw this arrow right, this is the remainder, and the remainder is nothing. So therefore 3 is a factor of this. That was quite quick, but that was kind of lucky, you could say, because it was trial and error, and you know how you can get lucky with trial and error. So x equals 3, or in other words, if you want to write it as a linear factor, you move this to the other side, not on the x, of course. X minus 3 equals 0, and that's your first linear factor. And so that's the first way of factorizing polynomials. So that method was quite long, because you remember probably from GCSE, again referring to GCSE, that trial and error is quite a long process. So we need a different method. So you can use that to work out if say you found factor and you want to test it out to see if it actually is a factor, you'll use method 1. So let's do method 2. Now we know from long division that if you want to find out, say, the factor of 40, say you want to find out if 5 is a factor of 40, we do 5 divided by 40, and hopefully if it equals 0, if the remainder is 0, then it's a factor. And so we know our 5 times tables, 5 times 8 is 40, we put a bracket there for later purposes. So 40 minus 40 is 0. Now that's not the second method, that's coming into the second method. So now it becomes more complicated. Let's rub this out. So let's see if x, say this linear factor, x plus 4 is a factor. Or not. We could plug this into this and see if it's a factor, or we can actually see what goes behind all of this, the mechanics of it, if you want to call it, see what happens. So let's do long division. So here's what we're going to divide. Minus 8x. I don't think I've given myself enough space. At this, and our divisor, we could say, call it, I think it's divisor. Don't really speak that much maths. So okay, let's do the usual long division. Let's forget about this side for now. Actually, forget about this whole side throughout this. Forget about the 4, just concentrate on the x. So we will say to ourselves, how much times there's x go into x cubed? And you would say to yourself, so you would say that something times x equals x cubed, so it will be x squared. Let's take off top part. Okay, we needed to get rid of that. Okay, so if you times, what do you times x by to get x cubed? So it's x squared. So x squared times x is x cubed, and 4 times 4x squared is plus 4x squared. Now this is all negative. As we know, when we do long multiplication, we always subtract the bottom side. You get what I'm saying, basically. Yeah, we'll subtract the bottom one. So this cancels out, and we're left with, this becomes minus, because plus and a minus is always a minus. So this becomes negative 3x squared. and the minus 8x comes down. Minus 8x comes down. Okay, and now we will see now. So now we finished with the x cubed. Now we've got an x squared. So now we'll say how many x's go into 3x squared. So would you times, how many times basically does it go into 3x squared? Minus 3x squared. So it will be minus 3x times, because minus 3x times x is minus 3x squared. So that will be minus 3x squared, and minus 3x times 4x is minus 12x. And remember, this is negative. We always subtract. I think I'm losing space. So this will cancel out, and this will come down. And because negative negative is positive, so this will be 4x minus 12. Let me try and make some space. Hopefully that was enough space. Where's the mouse gone? The mouse gone there. Okay. So now we'll finally say how many x's go into 4x. See, 4x. How many x's go into that? So we will say 4 times, just 4. So that will be 4x, and then 4 times 4 times 4 is 16, plus 16, because none of them are negative, and then it's negative here. So because it's in a bracket, that means everything was negative, and then I have no space. Yeah, so that will be simplified to this cancels out, this cancels out. This becomes minus 16 because a plus and a minus, so it's minus 28. And this is the remainder. Now, you could argue this is slower or the one before it was slower. Either way, both of these are slow. But I just showed you this. I just showed you this one to explain the first one. And the first one is commonly used to see whether it's a factor or not. And usually it comes up in many of the exams. In fact, it's come over a lot of the past papers I've done. So that's the second way. And now we will move on to the final and third way. And this is the way that probably most of your teachers would have told you. I might as well begin. So, oh, I forgot the 2. That was a poor entrance, poor edit out actually. So now the third method. So now we know from the first method that x equals 3, or we are given basically the first linear factor, so x minus 3 equals 0, and that's our first linear factor. Now for this method you will need at least one factor known to do this. So now we can set up this. Seeing as we have a factor, we can now set up this cubic into a linear factor and a quadratic. Now this is the beauty of this method. So you will set this up as 8x minus 12 equals, let's write equals, going with px. You'll now write equals to x minus 3, and then you will have a quadratic. Now, the only way you can make x cubed from x is to have an x squared. So that has to be in there. Now, we don't know how many x's we need, so we'll write plus bx. And then, as all quadratics have, they have a plus c. Now, c is the only one in this quadratic that doesn't have a coefficient of x. So therefore, it's the only number in here, in this equation. Remember, we're only looking at this quadratic for now. That will make minus 12. So something from here, something from this linear factor, times something from inside this quadratic equation, this linear equation and this quadratic equation. You can call them factors or equations. Depends on how you're referring them. So the only way you can make minus 12 from these two is if C is 4. So this is guaranteed that x minus 3, we've found out one unknown through inspection. So C has to be 4. Now, we realize we only have one unknown here. And we know that if we multiply this out, we can make B the subject, and then we can find out what B is, seeing it's the only unknown. So let's just use one coefficient for now. One, say, coefficient of x. Let's use x squared instead of using x. We'll just use the x squared. So what from here? What from these two? Remember this. Let me use a different color. This has to be multiplied by this to make this, right? Oh, it's there as well. Anyway, so this has to multiply by this to make this. So we know that this number and this number can only make 12. But what about when 3 times x squared? So let's work out B now. So 3 minus x squared, and then x times bx, so that's plus bx squared, equals x squared. This is the only way you can make x squared, right? Minus 3 plus 4, minus 3 times positive 4 won't give you x squared. bx, b lots of x times minus 3 won't give you x squared. The only thing that can give you x squared by multiplying this and this is minus 3 times x squared and x times b lots of x, right? So we realize that we have a common coefficient, and if we divide all by x squared, we can get rid of this, get rid of this, and get rid of this, right? And this becomes 1. Because if you divide x squared by x squared, if you divide any number by itself, it's 1, right? So that's 1. So now we have minus 3 plus b equals 1. Therefore, b equals 4. So now we actually know what b is, and now we have a linear equation or linear factor, and we have a quadratic factor, or quadratic equation. It's a factor of this equation here, this cubic equation. So now let's rewrite it. Let's rewrite this side. Hopefully there will be no confusion. So now x minus 3 and x squared plus 4x plus 4 is the new, oh, I forgot a bracket there, is the same as this equation here, right? And this is why I mentioned the revision stage, because now we have a quadratic and we have a linear, and from a quadratic we can get 2 linear factors, which adds up to 3, right? So now we have x minus 3. I always mess up that. And now we can factorize this. So what do you times to make 4, and what do you add? What do you multiply to make 4, and what do you add? What do you sum up to make 4? And that's plus 2 and x plus 2, because x times x is x squared, x times 2 is 2x, x times 2 again is 2x, so that's 4x, and then 2 times 2 is 4, right? So that's 3 linear factors. And in fact, if you want to look smart in front of the examiner, but hopefully don't mess it up when you do it, x plus 2 squared. I know it's nothing big, but it saves probably 1 centimeter on your page. So that was factorizing polynomials. I hope this helped. If you have any questions, please do message me on my channel. Thank you for watching, and goodbye.